This is Calc 1, section 1.3. Right, first, take a look at some of the problems. For those who don't have the book and aren't getting it, page 42. I'll show you the problems there. Some there. 5. And some more over here. Hmm. 29. Page. There. There. Remember, if I'm ever going too fast, you can always pause, rewind, fast forward as much as you want. And they go up to 53, I believe it was. There we go. And number 1, what happens to each of these graphs? So 3 units upward, 3 units up would be f of x plus 3. B, 3 down, f of x minus 3. C, 3 units to the right, f parentheses x minus c. D, 3 to the left, f parentheses x plus c. E, reflect about the x-axis, that's negative f of x. F, reflect around the y-axis, f of negative x. 3, stretch vertically by a factor of 3, 3 f of x. And H, shrink vertically by a factor of 3 is 1/3 f of x. Okay, here are some review of the way some functions work. Okay. So if I take sine x, which is an amplitude of 1, 2 sine x, well, it goes up twice as high and it goes down twice as low, but the zeros stay the same. Half sine x only goes up half as much and goes down half as much, but the zeros again stay the same. Okay, some functions you should be familiar with. It's x squared, negative x squared, x cubed, the general cubic looks like that. Cube root looks like this. Absolute value function, V shape. Okay. That red was to show you where y equals x goes, and then this part just bounces over to here. Square root of x looks like that. 1 over x looks something like that. Okay. Okay. Number 3, you're given f of x. So match each equation with your choices. So here's the given f. Okay, f parentheses x minus 4, that moves 4 to the right. So that's number 3. F of x plus 3, that goes 3 up. So that'll be number 1. 1/3 f of x, that only goes 1/3 as high. So that's number 4. D, negative f of x plus 4. The x plus 4 moves 4 to the left, but the negative bounces it across the x-axis. So that seems like this one. And then by elimination, you can get letter E. Okay. All right, now some of these functions that involve graphs. Let me show you what's happening with those. Okay, number 11, x cubed plus 1. So you take the general cubic x cubed, move up 1, x cubed plus 1. Number 15, you have to complete the square. Treat this as x squared minus 4x plus 4 minus 4. You might recall from completing the square, you take half the coefficient of x and square it, half and square. Half of negative 4 is negative 2, negative 2 squared is 4. Plus 4 minus 4. This factors into x minus 2 squared plus 1. So that's a translation of 2 to the right and 1 up. So I take my basic parabola y equals x squared. The vertex moves over to 2, 1, and then just draw the same thing. 19, y equals sine of half x. This is the b. Period is 2 pi divided by b. 2 pi divided by half is 4 pi. So this graph completes a sine function not after 2 pi, but at 4 pi. So 0, pi I'm at 1, 2 pi I'm at 0, 3 pi I'm at negative 1, and 4 pi back to 0. 23, absolute value of radical x minus 1. So here's my progression. Here's the square root function. Move it 1 down, square root of x minus 1. And then, so this is the graph right now. Absolute value of the whole thing, well, anything that's greater than or equal to 0 stays the same. But any part that's below the x-axis bounces over here, reflects across the x-axis. So I have this graph, curves like that, and then it continues on like so. So you end up with something that looks like that. Okay. 29b, y equals sine of absolute value of x. This is now an even function. F of x is the same as f of negative x. Okay, so I'll just graph this part here in quadrants 1 and 4. Okay. If I'm over here, the absolute value of x is the same as x, so I just draw the regular sine function. Then in quadrants 2 and 3, since I now know it's an even function, I just reflect across the y-axis. So I get this piece like so. So there's my entire graph. It's an even function. Okay, C, y equals square root of absolute value of x. If I only had this, I would not be allowed to put any negatives in. Since I have absolute value of x, I can put negatives. And furthermore, this now becomes an even function. If I plug in 7 or negative 7, I get the same thing. If I plug in pi or negative pi, I get the same thing. So I'll just take the regular square root function and reflect across the y-axis, and I get something that looks like that. Okay. And a quick reminder, so the graph of x greater than or equal to 0 stays the same. Then reflect the graph across the y-axis. So reflect across the y-axis. Reflect across the y-axis. Okay. What am I trying to show in this picture? The way absolute value works, you take the line y equals x. Anything that's greater than or equal to 0 stays the same. That stays the same. This part, which was below the x-axis, reflects across the x-axis and goes like that. So you end up with your V shape. Okay. All right, recall composition of functions. F circle g of x means f of g of x. So for 35, if f of x is that, g of x is that, f circle f means f of x, which is f of radical x plus 1, which is a square root of this thing plus 1, square root of x plus 1. G circle g, g of x, g of 4x minus 3. Take that 4x minus 3, plug it right back in here. So it's 4 times 4x minus 3, and that comes out to be 16x minus 15. Okay. The domain is all real numbers. F circle g, f of g of x, is f of 4x minus 3. And now 4x minus 3 goes right in here. So square root of 4x minus 3 plus 1, that's the square root of 4x minus 2. G circle f, g of f of x is that. So I'm taking g of radical x plus 1. And now this mess, all behind my pen, gets applied to the g function right here. So 4 times the mess minus 3. Okay. And then going back to part A, you have the square root of 4x minus 2. What is the domain? Well, 4x minus 2 has to be greater than or equal to 0. That means x is greater than or equal to half. So the domain is bracket 1/2 to infinity. F circle f is a little bit tougher. to find a domain. First, this thing has to be greater than or equal to 0. X plus 1 has to be greater than or equal to 0. That means x is greater than or equal to -1. This thing behind my finger, radical x plus 1 plus 1, also has to be greater than or equal to 0, but that's always going to be true wherever this is defined, namely when x is greater than or equal to -1. That's always going to be greater than -1. So the domain is bracket -1 to infinity. Okay, 32 asks for f circle g circle h. So it's f of g of h of x. I go innermost, h of x is x squared. And I apply this to g. G takes the sine of that. So it's f of sine of x squared. And then what does f do? Takes 3 times whatever you gave it and subtracts 2. So 3 times sine of x squared minus 2. And you can leave it like that. Okay, then we have 52 and 53 at the very end. F of g of 1. So first I do g of 1, 6. Then I take f of 6. Okay, so one more time, g of 1 is 6. Then I want f of 6, which is 5. G of f of 1. F of 1 is 3. And then g of 3. G of 3 is 2. F of 1. F of 1 is 3. Plug it back into f. F of 3, 4. G of 1. G of 1 is 6. Then I want g of 6, 3. So you have an intermediate function to worry about. G circle f of 3 means I do f of 3 first. So f of 3 is 4. And then I want g of 4. G of 4 is 1. Then f circle g of 6. First I want g of 6. So how much is g of 6? 3. And now I want f3. Try to get this a focus. F3, 4. Okay. And then 53 is pretty much the same thing, only they give you a graph. Okay, so f of g of 2. G of 2, blue graph. G of 2 is 1, 2, 3, 4, 5. And then I want f of 5. 1, 2, 3, 4, 5. I'm here. So where's here? 1, 2, 3, 4. Which means it's just 4. G of f of 0. F of 0 is 0. Then I want g of 0. 1, 2, 3. Okay. F of g of 0. I start with g of 0. G of 0 is 2. Then I want f of 2. F of 2, negative 2. G circle f of 6. That means I do f of 6 first. 1, 2, 3, 4, 5, 6. It's way up here. 1, 2, 3, 4, 5, 6. So now I want g of 6. G doesn't go out there. So undefined. G is undefined. G of negative 2. So G graph -2. See, where am I? G of -2. -1. Then I want G of -1. Oh, maybe 1.5. And finally, f of 4. F of 4, red graph, 1, 2, 3, 4. 1, 2, 3. F of 4 is 3. Now I'm just looking for f of 3. F of 1, 2, 3 looks like it's 0. Okay. Work. All right, so that'll do it for section 1.3.